Let's start this question off by drawing a sketch. So we have some kind of curve. We're not sure exactly what this curve looks like, but it's a curve, a parabola. We know this because we have an x squared term here as our highest power. So this will be a curve, and we want to find the equation of the normal at the point 2, 2. So let's say this here is our point 2, 2. Equation of the normal, if you remember, is the equation of the line that is at right angles perpendicular to the tangent. So if this is our point 2, 2 here, then we have our equation of the tangent and we have our equation of the normal. And we know that the equation of the tangent and the equation of the normal are related in terms of their gradient. The gradient of the normal multiplied by the gradient of the tangent equals -1. So if I find the gradient function of this function here, I do that by finding the derivative, which is 2x minus 1. So my function is y equals x squared minus x, and my derivative then is 2x, take down the power, take 1 away from the power, minus 1. And I know that this then describes the gradient, the steepness, at every point along this curve. Now, we're very interested in this point here, 2, 2, where x equals 2. So my gradient at this point here is where x equals 2. So my gradient equals 2 times 2 minus 1, which equals 3. So my gradient at this point here equals 3. And that's my gradient of this line here, this tangent. But I also know that I want to find the equation of the normal, and I know that the gradient of the normal multiplied by the gradient of the tangent is -1. So if my gradient of the tangent is 3, then my gradient of the normal will equal -1 over that gradient of the tangent 3. So I have a line now for the equation of the normal. It's a straight line, so it follows the form of y equals the gradient m times x plus c, where it crosses the line, the y-axis. And so I know it passes through the point 2, 2. So my y is 2, my x is 2, my gradient is minus third multiplied by 2 plus c. So from here I can find out what c is. So 2 equals minus 2/3 plus c. So if I add 2/3 to both sides, I get 2 2/3 equals c. So my gradient of the normal then is y equals -1/3 x plus 2 2/3. And I could multiply this by 3 to get it into a nicer form. I would get 3y equals -x plus, well, this is the same, 2 2/3 is the same as 8/3. So if I multiply this by 3, I get 8. So it would be +8. So I end up with 3y plus x equals 8. That's one way I could represent this. So this is my equation of the normal. Next, I've got to find the coordinates of the point where the normal hits the curve again. So this normal, if we extended it up here, would hit the curve again somewhere. Again, this is a sketch. It is not to scale, but it gives us an idea of this here. Now, this is the curve y equals x squared minus x. This here is a line that crosses it. So we could have a simultaneous equation, two sets of equations here. We've got y equals x squared minus x, and we've got 3y plus x equals 8. So to solve these two here, well, we have 3y plus x equals 8. Let's substitute in what we know as y here, and we'd end up with 3 multiplied by x squared minus x plus x equals 8, which implies that 3x squared minus 3x plus x equals 8, which implies that 3x squared minus 2x minus 8 equals 0. So here we've got a quadratic and we can solve this. Now there's a couple of ways we can do this. We can factorize. So we can do this by looking at, let's multiply our a times our c term. So a multiplied by the c, which gives 24. And if I can find my factors now of 24 to make my b term. So factors ac to make b. So I've got, well, I could have 8 and 3, but that only makes 11 and 5. I could have 12 and 2, but that only makes 14 and 10. I could have 6 and 4. Aha, that can make minus 2 because I could have minus 6 plus 4. So then I rearrange and I end up with 3x squared minus 6x plus 4x. So all I've done is rearrange this middle term here to look like this. Minus 6x plus 4x is minus 2x, and I've found this by using my factors of a and c. So I've just rewritten this equation here as this, and this then enables me then to factorize the two parts, and I end up with 3x into x minus 2 plus 4 into x minus 2 equals 0. So from that I can imply, let's take it up here, I can imply that 3x plus 4x minus 2 equals 0. These are my factors. And so x minus 2 is 0, and that ties in with what we know already up here, that it crosses here at x equals 2, because if x minus 2 equals 0, then x will equal 2. So that ties in with what I've got there. And then we could also say that 3x plus 4 equals 0, which implies that 3x equals minus 4, which implies that x equals minus 4 over 3. And that kind of ties into here, could be where it crosses the x-axis here at a negative value. Here we had 2, and here we've got minus 4 over 3. So the question was to find the coordinates of the point. So I therefore need to substitute that x value back into here, and I would end up with y will equal minus 4. Well, we could substitute this actually into either of these, and I'm looking at this, and this is probably easier. Let's substitute it into this one. 3y minus 4 over 3 equals 8. So therefore, let's multiply through by 3 again to get rid of this 3. We get 9y minus 4 equals 24. Add 4 to both sides, so we'll end up with 9y equals 28. And so y equals 28 over 9. So my coordinates are minus 4 over 3, 28 over 9. Now, I did say there's a couple of ways to solve this. Another way, when we're presented with this here, is to say that we already know that x minus 2 is a factor because we know that it passes through, or this is one of the points here. We want this point and we want this point, and this is one of them here. So when I've got this quadratic here, I could divide this, using my knowledge of polynomials, I could divide this by x minus 2. If I do that quickly here, so we'd have 3x squared minus 2x minus 8 divided by x minus 2. X into 3x squared goes 3x, so that's 3x squared. 3x times minus 2 is minus 6x. If I take those away, minus 2x minus 6x makes 4x, positive 4x. x into 4x goes plus 4, which will give me 4x. 4 times minus 2 is minus 8, and if I take those away, I get minus 8 minus 8 will give me 0. And so I can see that my other factor here is 3x plus 4, which is what I found anyway when I used the other original method. So either of these methods are fine. This may be slightly quicker, but this is my answer here.